Hi, hello everyone. Yeah, I hope everyone is doing well today. And yeah, I'm the last speaker. So yeah, today I'm gonna actually touch on WebRTC. And actually, the problem here that we are looking at is today we live in a world where we're increasingly overwhelmed by the sheer number of options and content we can access over the internet. So if we want to buy groceries, we can simply find 3 to 4 options to look for online. And of course, the year that has passed has tremendously accelerated the rate of all businesses to have online presence. And I experienced that activities like, seeing a doctor and lessons from formal school to enrichment classes and even gym classes, which I thought would not be optimal if it's not face to face, all become doable online. So hence, enabling online real-time communications is critical. Firstly, for any business or anyone who wants to capture the attention of people online, and of course, to be able to bring about all the kind of real-time interactions, see and hear each other virtually. And WebRTC is the technology that can be used for that. So RTC stands for real-time communications, and WebRTC is the open source framework which enables you to implement real-time communications in browsers using JavaScript and in iOS and Android, even native apps with the corresponding libraries. And WebRTC supports voice, video, and generic data to be sent between peers, um, allowing developers to build really powerful communication solutions. And there are many, many forms of different usage that are possible for WebRTC. Some examples here, which I see between 2 devices with WebRTC, we can do web chats, voice calls, and video calls, and enable real-time, even real-time games. We can even connect the WebRTC client to another party on the phone, and the media or data from the WebRTC client can be streamed to a server for further processing, such as recording it or even broadcasting it to more clients. For example, like what we have now in a Facebook or YouTube live session. And the diagram here sort of depicts what WebRTC does under the hood. So we as developers only need to interact with the API exposed, while WebRTC, which under the hood is implemented in C and C++, which takes care of transmitting the audio, video, and data. Which includes handling the encoding and decoding and also taking care of things like adjusting the bandwidth and quality of the video or audio and connecting when there are any fluctuations. But to dive a little bit deeper, you do need to take care of other things other than just calling the APIs to do WebRTC. And a bit of this network jargon here to connect 2 devices over the internet for what we call peer-to-peer connections. For WebRTC, the process can be broken down into signaling and media exchange. And signaling is sort of like the handshake process in HTTPS where the 2 clients need to exchange information, like the key for data exchange, codec information, IP addresses, and so on. And this signaling is not covered in the WebRTC API and needs to be handled separately. Secondly, almost all of us on the internet connect through a device, which does network address translation, or what we usually call NAT devices. So it could be home routers or firewall, which will sort of allow multiple devices to connect to the internet using one public IP address. So for devices not connected in the same network, they will need to send a query to this another server called a stun server to check on the device's public IP address. And in certain NAT devices, direct peer-to-peer traffic is not possible. Then we will need to use a relay server, which is called a turn server, where media can be transferred through that. So in all, an implementation of WebRTC, where we can expect any kind of devices from anywhere in the world, there is a need to cater for these few things: the signaling, the stun, and the turn service. And you can find a lot of sample code online on how to use the WebRTC API. And one very good source is webrtc.org. And to actually visualize what is going on, here's a glimpse of the sequence of API calls to set up the WebRTC call. So the main parties involved are the peers that we see here, the signaling server, and ICE. And ICE is a new concept here I'm introducing here, which stands for Interactive Connectivity Establishment, which essentially is the process of finding the different ways to connect the two peers. So this is handled by WebRTC, but you will need to sort of configure the stun and turn servers when we want to use the ICE to make use of all the possible routes to establish the connection. So inside the API, this is in particular in the JavaScript API, so RTC peer connection will be really the object where you will work to send and receive an offer and to send and receive media. And so we have seen that we can work with WebRTC API and need some backend setup for device communications to get WebRTC to work. And are there actually other complexities? So one challenge I experienced is the different browsers and devices that could possibly be used to access your WebRTC application. So definitely we hope that our app will be wildly popular and having tons of people wanting to use it. But there are a lot of things to tune and take into consideration in that case. For example, there are some nuances like screen share is not supported in the iOS Safari browser or other devices. And in a video call, we might get the best resolution of video displayed for the best experience, but we have to sort of balance that against the power usage and bandwidth available as well. So for certain devices, there's also experience of the phone, for example, overheating if you use certain codec and stuff like that. So this thing that I mentioned here, codec, we have not really touched on it, but it's basically a program for encoding and decoding data streams. So different devices and browsers have support for different codecs and optimization for different codec types. And all this means that we will actually need to put in some logic and decisions to be made to balance the browsers and devices that we want to support and the experience that we want to provide in your WebRTC application. And another point is with regards to the backend to support WebRTC. So we discussed that there's a need for signaling, stun, and turn servers required. So signaling and stun might not necessarily be a problem since they are only expecting traffic in the initial part of the WebRTC communication. But the turn server, when used, is expected in certain circumstances to relay all the data transferred, which could be pretty taxing. So we have to think in terms of planning for a scalable solution that needs to be properly thought through. So so far we've focused mostly on peer-to-peer connections. And if you need to support something like what we're experiencing now, a live session where there are a lot of people who might be connecting in to look at a video or a voice call, for example, a peer-to-peer connection where one client has to transmit data to 100 or even thousands of other clients, that is not really scalable. So your device and bandwidth just will not be able to support that. So instead, there are other architectures that suffice where data is transmitted to a central server to be retransmitted to other clients. So there are also some decisions on top of all that complexities to tackle when building a WebRTC application. But the rewards are definitely great with the level of engagement that I can see that we can achieve with our audience. And there are options for you to consider of whether you want to build your WebRTC solution or actually looked at some PaaS or SaaS solutions. So going purely open source, using the WebRTC library straight off will give you a lot of flexibility to integrate WebRTC into any part of your website or phone app. So this will possibly let you integrate the latest WebRTC offerings has to offer. But as usual, you will expect more coding and more logics to be implemented. And going PaaS has the benefits of extracting some levels of complexity, as it does some of the handling under the hood. And usually those solutions will handle the signaling, start and turn service for you, as in they might have this at the backend ready. But still some level of coding is required, and SaaS could give you the fastest time to market, but they will tend to give you a more generic experience and require launching usually another specialized app or browser window for the session, which depending on your use case, may or may not be what you want. So and what to choose really depends on what kind of experience that you want to achieve. So for example, on my own personal profile website, I'm actually using an open source WebRTC library to actually create a more engaging and interesting experience by actually allowing the video call to go directly inside the website. And some typical questions that we will ask ourselves when we consider what to use will be the cost on a particular solution. So actually the answer, there's no straight answer for this as usual. So you might hate it, but I will have to say that it depends on the expertise of your team and the solution that you're looking for, and the requirements that you are looking in your web app, or even your native apps in the phone. So that's it. Thank you so much for your attention throughout. Hope you enjoyed the talk. And now it's Q&A session.
Thank you, Sarah.
Thanks, Sarah. It was a great presentation. Thanks for sharing that. This is like super relevant to this new world that we're in right now, like extra engagement.
Yeah, I think while we are waiting for people to leave their questions on the live chat, we can go through some questions that we got from registration. So the first question is, how can WebRTC be used to perform telephone to web calls?
Yep. So for this part, there is actually a requirement to sort of have a middle tier or server that actually receives your telephone call and then translate your media into sort of a data stream that you can transmit in a voice over IP kind of format to connect to the whoever is over on the web. So basically on the web portion, this part will be handled by the WebRTC to actually be able to enable voice over IP to actually make phone calls possible over the web.
Okay, I hope that addressed the question. We've got one from the live audience, and yeah, so we've got some real questions from the real folks. So let's switch to that. So Wei Yan's got a question. So for the peer-to-peer connection brought about by WebRTC, can a communication be terminated from server side, like if it needs moderation or something similar?
Yeah, that's an interesting question. So if it is peer-to-peer, it means that it is a direct connection between the two clients and the two PCs. So there's actually, I think there's no way to really do the moderation or in between. So from my experience, if you want to do some kind of moderation or server-side kind of processing, you will need the media to go through a central server where just now I briefly touched on some other topologies that you will use in WebRTC For example, you will have something we call SFU server or a MCU server that will be able to go in the middle to publish or republish data streams, media streams, and then be able to from there to sort of take the data from one client and do some moderation before it is republished to another party.